Okay, so this is the first lesson in the 3U course, and we spend a lot of time on the first day of class graphing using tables of values. A lot of different types of graphs we're going to be using extensively throughout the course. Before we get into that, we're going to be looking at a whole bunch of key terms and definitions we're going to be using throughout. So first off, just to recall a bit from grade 9 and grade 10, you've worked a lot with different types of relations over the past couple of years. You may not have necessarily called them relations, but you did work with them. So a relation is anything that describes how two different variables are related to each other. Now, generally those variables have been x and y, but it can be absolutely anything. It can be someone's age versus their grade in school. Those could be two variables that could be described in a relation. It could be how high you are, how tall you are versus how fast you can run. That could be two variables, and you could again have a relationship between those. But some of the most common relationships that you saw back in grade 9 and grade 10, well, for starters, in grade 9 you worked extensively with lines. So y equals 3x plus 5, you would have worked a lot with something like that, and that would be an example of a linear relation. In grade 10 you stepped up a little bit more and you worked a lot with quadratics, such as this one here, which is in factored form. And you may have worked a little bit with circles in grade 10 as well. So this one here is a circle with a center at 6, -2 with a radius of square root of 51. And you may not have may not have worked tons with those, but you did work with them. And again, all these are simply just equations relating to variables. In all of these cases, though, the variables are x and y. Okay, so while a lot of the relations that you saw over the past couple of years have been in the form of equations, there's lots of different ways of describing relations. You can use graphs, which are very, very common. You can describe it using words. You can use tables of values, which you did a lot of back in grade 9 and 10. Sets of ordered pairs, i.e. just listing the points, and something called a mapping diagram, which you may have not seen too much of. Won't be too important, but we'll see a couple of examples of those coming up later on. So with any type of these relations, with any relation that you see, there's these two variables, usually x and y, that are related, and all of them take a specific input, which we call the independent variable, which is often x, and it produces an output, i.e. a dependent variable or a y that the relation generates. So with any one of these equations, you could take any x value, put it into the equation as your input, do some calculations, and get a corresponding y value or output that would go with that. Okay, so for example, again, doing something that you've done before, just not necessarily used these terms before. If you had the equation y equals 3x plus 5, we've made our input, i.e. our x, equal to -6. We could put that into the equation, and you'd see what we would get. We'd have y equals 3 times -6 plus 5. And then simplifying that, 3 times -6 is -18, plus 5 is -13. So we'd say that an input, or an x, of -6 would give us an output, or a y, of -13. Okay, so we use input-output a lot when talking about functions because the variables aren't always x and y, but the idea is always the same. With any relation, you can put in a specific input and get an output that goes with it. Okay, now to take this a little bit further, there's special types of relations called functions, and a function is what happens when you have a relation where each input only produces one output. So if you want to just go back and put this just in terms of variables that we've used before, each x value would only produce one y value. Okay, so what does that mean? So let's just take a look at for example, the line y equals 4x plus 6. Okay, I'm going to make a nicer graph in Desmos over here. Okay, so here's the equation y equals 4x plus 6. Now you can pick any x value that you want. Okay, I'm just going to take, let's say for example, -2. So when x equals -2, I can see on the graph they produce a point, one value on the graph over here. Okay, and it's going to be at about -2. Okay, but you see that when x equals -2, I only produce 1 point. And that's going to be true for any x value I pick. So let's say I take an x value of 3. I can go to x equals 3, follow up the graph, and again, I'm only going to produce 1 point. Okay, and it seems kind of straightforward, but because you have a situation where, again, every x value that you can pick will only produce one y value, this relation is also called a function. So since each x value only produces one y value, we have a function. Okay, it's also called a relation as well, but more specifically it is a function because, again, each x value only produces one y value. Okay, but then you have relations such as this one over here. So the circle that so this is the equation of a circle. So this is x minus 1 squared plus y plus 6 all squared equals 36. So let's take a look at that graph on Desmos. Okay, and all of a sudden you'll see here that there's at least one spot. There's many spots actually, but let's say I take x equals -4. When x equals -4, there's two different y values on this graph. One down here and one further on down here. Okay, and there's multiple spots where that happens. Basically anywhere on this circle this is going to happen, but there's x values that will produce more than one y value. So in this particular case, while it is still a relation describing how x and y are related to each other, we will say that is not actually a function. Okay, so that's the main difference between something that we would call a relation, something we would call a function. And the key that you're looking for is, again, if it's going to be a function, each x value can only produce one specific y value. Okay. So again, just to recap, you can describe these relations and functions in many ways. Okay, so just to rehash what we saw back on the first slide: words, tables of values, sets of ordered pairs, mapping diagrams, graphs, or equations. The most common ones that you're going to see in this course are graphs or equations, but we'll see some of the other types throughout this lesson and further on the unit as well. Okay, but most of what we're going to be working with is graphs or equations. Okay, so the nice quick way to determine if something is a function, the easiest way is if you have the graph to do something called the vertical line test. Okay, so if we can draw a vertical line anywhere on the graph where it intersects more than one point, then the relation is not a function, because that means a single x value has more than one y value. So let me just demonstrate that on the equations we just looked at. Okay, so here's our first line, the y equals 4x plus 6. So I've drawn a vertical line here that I can move left to right. For you, when you're doing this at home, it's probably easier to use a ruler, or just you can even use your hand moving from left to right as a vertical line. What you can see is, I'll zoom out here so you get a better look, but as I move this vertical line left to right, I'm only ever going to touch the graph once at all times. I'm never going to touch the graph more than once. Okay, so that means that every x value that's on there is only producing one y value, so we have a function. Okay, let's say I were to use the case where now we're looking at our circle. So right in here, the vertical line is not touching the graph, but you'll see all of a sudden, oh, I reach a point where this vertical line is now touching the graph more than once. So what that means is wherever the x value is, in this case looks around -4, I have two different y values. So as long as that happens once on the graph, where the vertical line touches more than once, then we know automatically we don't have a function, because again, all we need is one spot where an x value produces two different y values. So if you have the graph, the vertical line test is definitely the way to go, because you can very quickly see moving across whether it's going to be a function or not. Okay, secondly, you can do what's called an equation test. You can take an equation, rearrange it, and solve for y. Once the equation's solved for y, you can either sub in some x values to see if they produce multiple y values, or if you know what the graph looks like, then you can picture the graph and then use the vertical line test on it. So there's some options there if you want to do it a bit more algebraically. Okay, but with that in mind, let's try and take a look at some examples. So right here, there's 6 different relations, and I want you to let me know whether these represent functions or not. Now, the first 5 are graphs. The 6th one is an example of what I call the mapping diagram. That was mentioned very, very briefly in passing on the first slide, so you may not have seen too much of these, and that's okay if you haven't. Okay. They're not super complicated to get the hang of once you figure out what they're actually trying to tell you. So in general, your independent variables on the left for these and your dependent variables on the right. So what this is saying is that when x equals 2, y equals -1. You just follow the arrow over. So when x equals 4, y equals -5. So really what this is a series of points that are going to make up your relation. So it's not going to be a nice, fluid graph like this, just a selection of points. So with that in mind, I want you to take a look at these 6 relations right here, and quickly just jot down whether you think they're functions or not. And when you're ready, so try that on your own and pause the video. When you're ready to go through the answers together, push play and we'll go through them together. Okay, so let's try and run through these together. So I've created a vertical line here, so from the graph I can do the vertical line test. So I'm going to move left to right on here, and I can see, oh, there's multiple spots, but here's one where I touch the graph more than once. So this one is not the function. It is not a function. So not a function. Okay, for the second one here, this parabola that's opening up, I can see that as I move from left to right, I'm only ever going to touch the graph once at all times, so this one is a function. So I'll write f for function just to keep things short. Okay, for the third one, let's take this vertical line test. You can probably already see it now, but you see you touch the graph more than once here, so this is not a function, so I'll use nf for that. And similarly, you can see how 4 and 5 are going to work as well. 4 is not a function. It fails the vertical line test lots of places, but there's one place it does. Okay, and 5 passes the vertical line test. You only ever touch the graph once at any time. Okay, now as for number 6, just so we get an idea of what's going on here. Now this one is actually not a function, and the reason is, if you look at x equals 6, when x equals 6, you produce two different y values, one at y equals negative 3, and one at y equals 3. So if you were trying to visualize this on a graph, okay, and you're trying to plot these points, so for example, when x equals 2, y would be negative 1, when x equals 4, y equals negative 5, you can plot all those points, but most importantly, when x equals 6, let's say it's out here, you can have a point at y equals negative 3, which is somewhere down this quadrant, another one at y equals positive 3 up in this quadrant. So even taking that vertical line test, you can see it's going to fail at only that one spot, but it will fail nonetheless. So this one is not a function. So remember, what you're always looking for to see if it's not going to be a function is an x value that produces multiple y values, like this case right here. Okay, so let's just go through a few more examples, and then we'll call it a day for the lesson. So looking at number 7 here, this is just a series of ordered pairs or points. So we have the point negative 2, 7, 3, negative 10, 5, 6, and 9, 7. You can graph these if you'd like to get a visual, but again, what we're looking for to satisfy if it's a function to see if there's any x values that produce multiple y values. Well, in this case, all of our x values are actually different, so there's no way they can produce multiple y values because they're all unique x values. Okay, where some people can get a little bit tripped up is they'll see two y values the same and all of a sudden think, oh, this can't be a function. But remember, these are the same, these two y values, the same y value, sorry, is coming from two different x values. So again, on a graph, you'd have a point negative 2, 7 up here, and that 9, 7 somewhere up in this quadrant. So this has, the vertical line test has no problem with this. It's only ever going to touch the graph once. So this one is a function. Okay, as for number 8, take a quick look at the table. And at first glance, it seems fine until you see that when x equals 2, we get y equals negative 3, but also y is going to be equal to negative 6. So because of this problem right here, this one is not going to be a function. Okay, so number 9. Now, I don't expect you to know how to graph number 9 yet at this point in the course, although it does look suspiciously like, in terms of the equation, something like one of these parent graphs that you graphed yesterday in class. So if you remember the shape of y equals root x, it just looks something like this, okay, which certainly does look like a function. And this would be very, very close as a transformation of that. In fact, it's actually just this shifted left 5. So I'll show you what it looks like on Desmos. Okay, so you can see that graph there, and this will very clearly pass the vertical line test, so it will be a function. We're going to spend a lot of time this unit learning how to graph these accurate without you having to use Desmos or any other kind of graphing technology. But for now, you can see from the graph that's definitely going to be a function. Okay, number 10. Hopefully you can tell from the equation this is going to be a circle. This is a circle with a center at 0, 0, and a radius of 5. So I'll show you a picture, but hopefully if you picture any circle drawn on a graph, you can recognize this is not going to be a function. So that one's a function, this one is not a function. So just to show you a picture of it, okay, you can see there that it's clearly not going to be a function. Okay, a couple more. So number 11, now, again, you worked a lot with quadratics last year, so hopefully you could tell me, if you had to, everything you wanted to about everything you needed to about this. So direction of opening, x-intercepts, y-intercept, vertex, and all that. If you forget some of that, that's something you should remember from grade 10, but we are going to review it a bit as needed, so don't panic yet. The important thing for now is you recognize that this is going to be a parabola, and a parabola opening down, so that should tell you that it's going to be a function. Okay, number 12, if you look at 5x plus 2y minus 7 equals 0. So this, if you remember from grade 9, is the equation of a line in standard form. If you're ever not sure, you can always rearrange the equation to solve for y and you get something in slope-intercept form. But this is a line, okay, and this is also going to be a function. So just to quickly show you the pictures of these. Okay, you can see that the parabola is going to pass the vertical line test, and the line will pass the vertical line test as well. Okay, and last but not least, this equation here, I don't expect you to know how to graph just yet. I'll show you what the graph looks like. It has a y squared in it, and it actually looks like a sideways parabola. So you can see from the graph that this is not going to pass the vertical line test. Okay, so this one is not going to be a function. Okay, so as a bit of a hint, anytime you see y squared in the equation, you can tell right away it's not going to be a function. I'm going to leave you to think on your own why that's going to be the case. So try and reason out why that would be the case. If you think about it and you're not sure, come ask me and I'll show you why. But again, anytime you see y squared in the equation, it's not going to be a function. That can be your clue right there. So other than that, there's homework there, and that's it for this lesson. That's it, that's all.